All right, this is 5.3 exponential functions, or I'm sorry, logarithmic functions, and their graphs. I am working on part 2 here. We're going to convert the following to logarithmic equations. These are, right now they are exponential. We're going to transfer them into logarithmic equations. So here, if you take a look, here we know our base already. And we're told our exponent is an x, so that's going to be on the other side of the equation. So really what we're going to have is a case of our log base 2, 16, and that's the x. All right, so let's take a look at our next one. This one is 10 to the negative 3 equals 0.001, which is tens, hundreds, thousandths. So in this case, we're going to have an exponent of negative 3 on this side, and then we'll have the log base 10, and then this number, the 0.001. All right, so we have, this gives us our log base 10, 0.001, and then our negative 3. That's our exponent on that. In this case, our exponent is the t. So we're going to have, I would say, probably, well, we would want to go log base e, which is an ln. We'll talk about that a little further in. We're going to have a 70, and then the answer is going to be a t for our exponent. So here it says, gives us our log base e, which is 70. So our exponent on that is a t. So now we're going to go the other direction. We're going to go from logarithmic to exponential. So this is actually really cool to be able to go back and forth between the two. It's really helpful to understand what's happening there. Okay, so we're going to have a 2 for our base, a 5 for our exponent, and that's going to equal 32. All right, so 2 to the 5th equals 32. In this case, our a is the base, and we're going to have 8 as our exponent. So a to the 8th is going to give us q. Right? And then here I have our t is going to be our base. Our x is going to be our exponent, and that's going to equal m. All right, hopefully this is all starting to like gel together, so it's making sense. You can do this on your calculator, and I suppose I should pull up the calculator app. I want to just quick show you where things are and how to go ahead and put them in. So here we're asked to find a log, and if you look, there's 2 things that are right here. The one right next to the 7 is a log. It doesn't have any number attached to it. So we understand it to be log base 10. Sort of like when we have an x, we understand that we have a 1x. So this is going to be our log base 10, and then below it we have an ln, which is a natural log, and that is based on the number e, which is 2.7281828 something on from there, something like that. So it's another one like pi. All right. So here I'm going to go ahead. Now, come on. Right there. I'm going to quit out of here. Clear that so we can see what's going on. I'm going to hit my log, and then I'm going to type this value in. All right. So I'm going to have a 6, 4, 5, 7, 7, 8. I'm going to close that. Now before I go any further, I'm going to pause and think about this. I want to be sure that I understand what's happening. So in this case, all right, in this case, I have a, let's see here. I want to get my, well, it's not allowing me to get to my marker, but I want to make sure I have something between the the 100,000 and 100 mil, or the million, right? So I know that I'm going to have 1, 2, 3, 4, 5, right? I'm going to have if I would have a 100,000, I would have a 1 and then 0, 0, 0, 0, 0, so that's going to get me a 5. And if I had a million, right, I'm going to have a 1 and then I'm going to have 6 zeros. So that would mean I would be to the 6th power. So I'm looking for an exponent to be between 5 and 6, and that's exactly what we have. All right. Same sort of deal here. We want to get this so that it's no longer going to be in this form. We want to have it so that we're here. So it's tens, hundreds, thousands, 10,000s, 100,000s. So 1, 2, 3, 4, right? So then we're going to be looking at something between 4 and 5. So this is going to be that number. And then here's interesting. We have log base 10 negative 3. And I want to actually work this out with you on the screen. Let me just quick show you. That would give us that 5.81 0.101. All right, that's rounded up. So on this, we're going to take a look at the log negative 3. So log negative 3, and it's going to tell us we have no real answer. There's no real solution to it. Now, that does not mean there is no solution. It just means there is not a real one. And I want to actually go to, and then I'm going to go into my mode and change things just a little bit. I'm going to go down to my real, which is the second from the bottom there, and then I'm going to go over to the a plus bi. So I'm saying I want to write it in a complex number. So I'm going to go ahead and hit my enter, and then I'm going to quit out of here, and then I'm going to go ahead and hit that log negative 3 again, and you can see now I have a real part, and then I have this imaginary part. So there is a solution. It's just that it's a complex number. Helpful to know if you've got a real number or not. It's much easier to deal with those. So we're going to go back. I'm going to put my mode back to reals, but I wanted to make sure that folks know that just because it says no real solutions does not mean there is no solution. All right. So here we go. We're talking about natural log. So ln is the same as saying log base e. And remember, e is this number of 2.78 something. Here, hang on. I wanted to show this. So I'm going to quit out of here. And I'm going to use my e to the first power. So I'm going to have just an e. I have a 2.718281828. And it does actually go on from there. So here we're saying this is our base. So, and it comes up so often in finance and in science that we actually are just like, okay, this is almost as useful as having log base 10. So we're going to give it its own thing. We're going to call it natural log. So it's ln, and that's the same as a log base e. All right. So whenever you see that, if you have a log base, an ln, you have log base e. And just a reminder, anytime you have a 1 involving some kind of exponent, that exponent is going to be a 0. Right. And anytime you have the original base back out of it, you know your exponent was 1. All right. We've gone over that before, but it still holds. I want to make sure that everybody's like super clear on that point. All right, I'm going to stop here and I will resume